welcome to this first instructional how-to video on how to convert binary into hexadecimal. This is a really common exam question and quite often it's overlooked. It is very, very simple to do. However, often it is skipped or just not understood. So, I'm going to go through step by step quickly how you can convert a binary number into a hexadecimal number. First thing which you wish to do is you're going to need 4 binary digits. Now binary digits are either zeros or they are ones. So I have this number by here, I have 1, 0, 1, 1. As we know that binaries can be zeros or ones, hexadecimals can be between the numbers 0 through to 9. And then after 9 it goes A, B, C, all the way through to F. And that is how 16 is represented within hexadecimal. So binary can either be ones or zeros, however we can represent 16 different digits in hexadecimal, as hexadecimal is base 16. In order to make the conversion from binary, which is this, into hexadecimal, you first need to break it down into bits of 4. So I have my first binary bit of 4, 1, 0, 1, 1. So the first thing we're going to do is I'm going to write a small 1 over the last digit. Each of these 4 numbers signify a type of number the decimal system represents. So this one will be a 1, this one is representing a 2, this one is representing a 4, and this one is representing an 8. Then we're going to go a line down. We're next going to say, okay, is the number 1 on? Well, it's representing a 1, so yes, it is on. Is the number 2 on? Yes, because there's a 2, so I'm going to have a 2. Is the number 4 on? No, because there's a 0, so I'm going to have a 0. And is the 8 on? Yes, it is, so I'm going to have an 8 like so. Now I have 8, 0, 2, and 1. What I can then do is I will add them all together. So I'll do plus, plus, and plus. 8 plus 2 is 10, plus 1 is 11. So this is how hexadecimal is represented out like so. We go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. Now, how am I going to convert this into something like this? Well, if I add 8 and 2, and that I get 11. Like so. And, okay, I'm first going to count out how this can be represented. So, I go, how many digits would this normally be? Well, normally we start counting from 1. Okay, so this is our normal counting system. You can see that I go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 10 would be equal to the A, 11B, 12C. So I can say like that. So if my 10 is equal to an A, what do you reckon my 11 would be? So my 11, which is over here, what do you reckon this would be? It'd be a B. So this number over by here is represented as a B. Let's do another one. So let's say I have the digits 1, 1, 1, 1. The first thing I'm going to do is I'm going to do the same steps again. I'm going to write the 1, 2, 4, and 8 above. 1, 2, 4, 8. And then take it down. So in this instance, each of them are on. So I would say, is this 1 on? Yes. It's a 2 on? Yes. It's a 4 on, yes, and it's the 8 on, yes. I'd add them all together, like so. So the 8 and the 2 equals a 10, and the 4 and the 1 equals a 5. Add them all together, that's 15. We look over to our reference, where does 15 come? 15 would be the F, so this would actually be represented as an F. So the 1, 1, 1, 1 is represented as an F. I next have 1, 0, 0, 1, 0, 1, 1, 0. Now, how am I going to represent this within hex? So you're going to do the first step again where I break it down into 4s. So I'm going to have a look down my middle. I have luckily 2 sets of 4s. I have a 1, 0, 0, 1 and a 0, 1, 1, 0. Now, what can I do with this? I'm going to do the same thing again. I'm going to take them down by doing their digits above, but I'm going to treat them as 2 separate things. So I'm going to go 1, 2, 4, 8, 1, 2, 4, 8. And at the end, I'll bring them together. So let's take them down. Over this side, the 1 is showing a 0, so that's going to be a 0. The 2 is showing a 1, so that'd be a 2. 4 is on, but the 8 is not. And on this side, the 1 is on, 2 isn't, the 4 isn't, but the 8 is. Okay? I'm still going to be treating these as separate, so I'm going to keep my line going down. I'm going to add them all together. On this side, I get a 9, and on this side, I get a 6. And I don't need to convert into the A's or the B's or the C's, so my end value would be 9, 6. So that value up by here, this 1, 0, 0, 1, 0, 1, 1, 0, equals 9, 6. Okay, so this final one is a long one, so we're going to break it up. So the first step again is break it into 4s, like so, and I'm going to take these lines down just so I don't have to keep writing them, like that. Again, I'm going to check which ones are on by entering the numbers above which they represent. 1, 2, 4, 8. 1, 2, 4, 8. 1, 2, 4, 8. And then I'm going to take them all down. But in this case, I only have the 4 and the 8 on, so I'd have a 0, a 0, a 4, and an 8. In this case, I have a 1, 0, 4, and an 8. This one, I have a 0, 2, 4, and an 8. So, I'm going to add these all together. So I'm going to add plus signs in between them, so the 8 plus 4 plus 2 plus 0, 8 plus 4 plus 0 plus 1, 8 plus 4 plus 0 plus 0. 8 plus 2 is 14. 8 plus 2 plus 4 is 14. 8 plus 4 plus 1 equals 13. And 8 plus 4 equals 12. Now, each of these can't be represented in the normal binary system, so I'm going to have a look at 14. 14 equals an E. 13 is going to equal a D. And a 12 is going to equal C. So I'm going to end up with this number equaling EDC. And that is how you convert from binary into hexadecimal. Have a go at the activity sheet and then submit using the form.